Welcome, everyone, and thank you for joining us. Today, we are honored to have Dr. Ron Turner presenting Introduction to NASA's Dream Shop, the NASA Innovative Advanced Concepts Program. My name is Janelle Slade, and I will be hosting today's webinar. A quick welcome before we get going. I would like to welcome our new Radiation Research Society Association Manager, Erica Hand. We are grateful to have her step into such an important role, and I can tell you she is already hard at it. Now, today's webinar is approximately 45 minutes, followed by a question and answer session. Please enter any questions you may have into the Q&A box, and we will address them at the end of today's presentation. If you would like to turn on closed captioning, you can do so by simply clicking the Show Captions button at the bottom of your Zoom window. Now, registrants can expect to receive a recording of this presentation via email within 5 to 7 business days. Before I introduce today's moderator, I would like to briefly mention, please be watching for the open registration announcement for RRS's 2024 annual meeting. The event is set for Thursday, September 15th through the 18th, 2024 in Tucson, Arizona. Now, registration is set to open on Monday, March 4th, 2024. We hope you can join your scientific colleagues from around the world as RRS converges on the breathtaking Sonoran Desert. I am so very pleased to introduce today's moderator, Dr. Josh Walker. Dr. Walker is a thoracic radiation oncologist and physician scientist at Oregon Health and Science University, with a primary appointment in the Department of Radiation Medicine and a secondary appointment in the Department of Cell, Developmental, and Cancer Biology. He is the co-director of the OHSU Radiation Biology course and is actively involved with resident and medical student education. His basic science research portfolio includes work in cancer and antiviral vaccine development, T-cell immunobiology, immunotherapy partners for ablative radiotherapy, and gene therapy construct development. Dr. Walker is the current chair of the Radiation Research Society Education and Website Committee and serves as the Astroscience Education and Program Development Subcommittee. He is also a member of SWOG and serves on the Lung Cancer and Radiation Oncology Committees. And with that, it is my pleasure to welcome and turn things over to Dr. Walker. Welcome.
Thank you very much, Janelle. It is my pleasure to host this webinar today and to introduce Dr. Ron Turner. Dr. Turner is a distinguished analyst with the Analytic Services Incorporation, aka ANSWER. He has served as the Senior Science Advisor to NASA Innovative Advanced Concepts Program since 2010. For 9 years, he was the ANSWER point of contact to the predecessor of NIAC. The NASA Institute for Advanced Concepts is an independent institute charged with creating a vision of future space opportunities to lead NASA into the 21st century. He's an internationally recognized expert in radiation risk management for astronauts, particularly in response to solar storms. He participates in efforts to understand NASA's requirements for operational space weather support. In 2021, he was selected to serve on NASA's Space Weather Council, advising NASA on space weather research and operational support. Dr. Turner's contributions to NASA were recognized with the award of the NASA Exceptional Public Service Medal in 2015. His advanced degrees in physics include a PhD from Ohio State University and a master's and bachelor's degree from the University of Florida. We have been looking forward to this presentation, and with that, I'd like to welcome Dr. Turner, and thank you for joining us today.
Thank you very much for that great introduction, and I'm really looking forward to sharing the fun of NIAC and the value of NIAC to the audience today. I'm going to start by playing a short video about NIAC.
Science fiction shows us the incredible potential of innovation. Sci-fi dares to defy what is possible. And NASA helps make it a reality.
NASA dares to make the impossible possible. That's only because the innovators, thinkers, and doers who are helping us imagine and prepare for the future of our space exploration are the wizards working on this NIAC program.
The NASA Innovative Advanced Concepts Program enables innovators across the country to test the concepts that could change science fiction to science fact. NIAC studies revolutionary concepts to figure out how to gain new capabilities and enable missions that are either impossible or too costly today.
NIAC is essential to the future of space. We reach out to those who are captivated by big ideas in that never-ending pursuit of what's possible.
NIAC funds technically credible, visionary space and science concepts from diverse and non-traditional sources, both inside and outside of NASA.
The NIAC program helps give these forward-thinking scientists and engineers the tools and the support they need to spur technology that helps future NASA missions.
NIAC will boldly transform the future and extend the boundaries of what's possible to help NASA write the next chapter of space exploration.
So hopefully you were just as excited by that video as we were to have, participate in producing it. What I'm really proud of is that NIAC, as a very relatively small program inside NASA, we border on the just over 10 million a year. Very honored that the administrator and associate administrator both wanted to chime in to give some support to our program. They're both very strong NIAC advocates, and that's very it's very gratifying to us in the program. Of course, we in the program think it's great. It's nice to see that there's other people within NASA that have the same view. So what I'm going to talk to you about in a little more detail is this thing that we like to call NASA's Dream Shop, the NIAC program. NIAC's been around for close to 20 years in 2 incarnations, as you may have gleaned from the intro. There was an initial NASA Institute for Advanced Concepts led by Dr. Bob Casanova, and I was fortunate enough to have been in on the ground floor supporting the original NIAC for 9 years. Then there was a hiatus and then a reemergence of NASA, of NIAC within NASA a couple of years after the original one was closed. And the one I'm talking to you about is the reincarnation of NASA, of NIAC within NASA. So what exactly is this thing called NIAC? We're a NASA program in the Space Technology Mission Directorate, designed to change the possible in aerospace. And we take that very, very seriously. We really are here not for incremental improvements, but really those grand visionary changes. We're also a diverse community of fellows. When you are awarded a NIAC grant initially, you are given the title of a NIAC Fellow. And once a fellow, always a fellow. We maintain a close-knit community of NIAC Fellows and a broader collection of enthusiasts for NIAC. So once a fellow, you're always a fellow, and really that's one of the things that really does set NIAC apart from many tech development programs. We don't just give you the funds to do your studies. We welcome you into the community. What do we do? Well, we do fund early studies of innovative but credible visionary concepts. But in addition to that, we support a wide range of communications and outreach opportunities, and I'll touch a little bit on that later. Why we matter is that we both from the work that we do, the actual funded studies that we hope will have an impact in the future, but also we exist to let the community know that we're here to inspire innovation. We're here to engage and inform the public and get the public excited about NASA and future aeronautics. How do we do this? We fund programs in what we call 2 phases. Phase 1 is a short study, about 9 months long, 175K, that basically gives you an opportunity to show that this weird idea that you have actually might make some sense, to establish the feasibility of the core idea. And then some of those phase 1s get selected subsequently, competitively selected subsequently for a phase 2, which is about 2 years, about 600K, where you go into more detail once you've established the fundamental feasibility and try to both further establish the feasibility, but also to develop a roadmap for how your idea could be implemented in the future. In very rare cases, we fund what's called a phase 3. Phase 3s take a phase 2 that not only has proven successful, but also has demonstrated a poll by somebody in the community that says, if these guys can just do and show 1 or 2 more key things, then we're willing to invest serious money in this activity. So you can imagine that there's 2 valleys of death in innovation. There's the initial one where you just want to show that your idea works. That happens, that's addressed in both phase 1 and in phase 2. Then there's a later valley of death for the more mature concepts that maybe has shown their mettle, but they still need some help getting that additional support for implementation. And that's the reason for phase 3. Now, in terms of numbers, phase 1s, we aim to award about 15 of these a year. The last few years, it's been more of 12 and 13. Steady state is really on the order of 15 to 16. Phase 2, we aim to fund 6 to 7. The last couple of years, it's been on the order of 5 to 6. But the steady state is expected to be about 6 to 7 phase 2s a year. Phase 1s is 1 a year, assuming that there is an eligible contender for a very tight set of constraints on what makes a phase 3. And if we have a chance, we can go into that in more detail later too. Again, I mentioned that we are in the Space Technology Mission Directorate at NASA. That's one of the, if you're not familiar with NASA, NASA has a Science Mission Directorate that manages the budget for science-related studies and missions. They have a Human Spaceflight Directorate. The name fluctuates with time. That's actually, there's 2, one that looks at the far-term types of human missions, and one that's responsible for operating the current missions. So those are the human mission directorates. It has an aeronautics mission directorate. It's the first A in NASA. And NIAC is also able to fund not just space applications, but also aeronautic applications, even though we're in the Space Technology Mission Directorate. So the Technology Mission Directorate is the other mission directorate, and it addresses cross-cutting technologies that help across all of NASA. And we in particular, NIAC, are in the early stage phase of that. We're at the very front end of exploring interesting ideas. So in general, there's Arthur C. Clarke has these 3 stages of reactions. It's completely impossible. Well, it's possible, but it's not worth doing. And then finally, I said it was a good idea all along. NIAC works mostly on trying to get something between step 1 and step 2. But again, we're more than just a research grant opportunity. Not only do we provide those funds to allow you to explore your concept, but we also have this fellowship. And we have an outreach coordinator, Kathy Riley, who is extremely good at reaching out to museums, to the media and other outlets to help explain what we do and to make what we do accessible to the public. All of our reports are posted on our website. When you get to the end of one of your studies, you submit your final report. It goes on the website to be accessed by the public. If you look right now, we're having a little bit of a lag in getting the reports on, because once the report goes on, it has to be fully accessible to those with disabilities and everything. So there's sometimes a lag in getting the final reports, but the final reports are all intended to go onto our website for full visibility to the public. When I say we inspire innovation, we do more than just lay claim to those things that we directly fund. We have as an example the helicopter Ingenuity that flies on Mars today. The existence of that helicopter can be traced through the Ingenuity designer himself to having walked in on a presentation by a NIAC fellow at a university at Stanford. So Bob Barlam saw Elon Crew present his idea for a Mars helicopter. Bob decided, I think that could really work. I don't think it's going to work quite the way Elon says it's going to work. Ian says it's going to work, but I think we can make that work. And through the course of another decade, it eventually resulted in the Mars helicopter. So what we try to embrace is the idea that innovation is important, and we want to know that NASA is open to innovation, and so we fund these ideas that are innovative to help push those boundaries. Of course, what we do is very exciting. Not only do we think so, but the media thinks so as well, and we're very proud of that. Again, Kathy Riley helps moderate a lot of that and helps monitor a lot of that. But we get a lot of press, and we're pleased to say that almost invariably the press gets it, and they're excited also by what we do. So when you become a NIAC fellow, when you begin your study, it gives it's a huge force multiplier. You can see that the public really does look to NIAC for interesting ideas and try to follow what we do. Now, who are we open to? We're actually open to just about anybody in the US, any US person. We fund universities, national labs, industry, small businesses, NASA researchers, and even individuals and garage inventors. All you have to have is a code that NASA can use to figure out how to pay you. And that code is developed in order to apply to Inspires, which manages all of the call and the selection of proposals. But the point is that you don't have to be in any one of these slots in order to have an ability to file and compete for a NIAC grant. And we're really proud of the fact that without putting any quotas in place, about a third of our awards have gone to NASA researchers. About a third of our awards have gone to academic sources, and about a third of our awards have gone to national labs, industry, other. So we really do have a distribution of where these awards go. And you can see that we funded across the nation. If you happen to be in one of the states that's not represented here, we'd be pleased to hear from you. We'd love to color this chart in a little bit more, but this is the state as of last year on the distribution of how our awards have gone so far. And again, we're awarding both NASA, business, industry. These are the ones that went to non-academic locations. So what makes a NIAC Phase 1? It has to be, of course, innovative and high impact. Has to be something, an aerospace architecture proposed in a mission, in a reference mission, credible and reasonable. All of these are important. Innovative and offer high potential. We're not looking for evolutionary changes. We're looking really for those really far out ideas with that could potentially change the future. It has to be aerospace in a reference mission. This is really important, and one of the things I'm going to get back to in more detail. We, in a sense, NIAC is not a technology development program. We don't fund you to take your innovative widget and just simply iterate and improve and study your widget. What we do is we give you the opportunity to show that your secret sauce, okay, when employed in a mission context, gives NASA the reason to come back and fund your idea in more detail later. So we're not actually funding you to do fundamental research or technology development and improvement on an individual widget. We're funding you to show why your widget could change the future. And you do that by putting your idea in a mission context and a specific representative mission, and show us the value of your idea by showing us how that improves that mission. Now, the mission can be pretty open-ended. It doesn't need to be, in fact, it doesn't have to be a NASA mission. It could be anything, an aerospace mission. It doesn't have to be an identified NASA mission. It could be a brand new NASA mission. It could enable a mission that nobody ever thought of before. So it has to, however, be credible and reasonable. You know, we're not going to fund a warp drive concept unless you really have a strong argument that convinces a peer review that your warp drive argument is, your warp drive concept is really worth exploring. So it has to be in the realm of the credible and the reasonable, but we like it to be on the edge of that range, okay? Again, any field of study, and the great reason for coming and talking to this community, radiation research community, is because we want to tap areas that don't typically think of NIAC as an opportunity for study. We like to go into as wide a range as we possibly can. So how do we do this? Phase one, in order to get a phase one, the very first thing you have to do is, after we release a call, which goes out generally the beginning of June, you submit a 3-page white paper that describes your idea. This is your step A submission. We review those step A proposals, and the ones that we think are qualifying, we invite, and competitive, we invite to step B. Step B, that's only an 8-page proposal. But in the 8-page proposal, now you flesh out the teaming arrangements, the costs, you know, exactly what you would be doing in the course of your study. Okay, so it's a 2-step process, and it is arguably the most competitive process in all of NASA. We get around 300 we get over 300 step A's the last several years, pretty steady state over 300, around 300 step A's. We invite on the order of 100 of those to step B, and of that 100, we fund on average something like 15. So it's still incredibly competitive, but it's very worthwhile. And so, you know, again, that's why the 3 and 8 pages, we don't believe it to be too terribly onerous either. Now, there are some things that we note in the call are some elimination criteria, some things that if you, these are what we call the thou shalt not criteria. If we get a step A proposal that meets any of these criteria, that is not an aerospace concept, is not previously explored, does not put in a representative mission, then we deem it to be out of NIAC scope, and it is not invited to step B. If you meet all these 9 criteria, if you are within scope, we still look at the 300 or so submissions and make a competitive assessment. You know, is this going to be worth, have you demonstrated that this is worth the time of a technical review panel for selection? Generally, we're pretty soft on this, on the second step about competitiveness. We recognize that we're not the experts that a technical panel can bring to bear. But on the other hand, it is also another filter to whether you get invited to step to step B. And one of the things that I want to make sure everybody on call knows is if you aren't quite sure if your idea fits within a NIAC scope, the best thing you can do is reach out to me and talk to me. I can, in effect, coach you into staying in NIAC's scope as long as we begin the dialogue, and the dialogue is ended by the time the call goes out at the beginning of June. So if you become uncertain about whether your idea is within NIAC scope, then you can reach out to me. And I believe my contact information is included either in the early slides, or if not, we'll make sure it gets to you. So that's another step, because we recognize that NIAC is different from a typical research or tech development organization. The hardest thing for most proposers to understand is this idea that we're not going to fund your widget, but we're funding you to show why your widget should be funded by putting your concept in a representative mission scope. We don't fund isolated technology development. We should give you an opportunity to show why your idea concept matters and should be funded. So what are some examples? I'm going to give you one sort of detailed example at the end that I think is, reflective of what the countermeasures community may have to offer. But some general examples, a new propulsion idea. If you've got a new idea for getting somewhere fast, well, what's the total system mass? Where would that matter? What are the alternatives? How much payload could you deliver when to where? Okay, not so much the working details of the concept in too much focus, but if it does work, what is it going to give us? If you have a new instrument idea, how would that instrument fit in a spacecraft, land, or rover? What are the mass, power, communication requirements for your instrument? In other words, if you got a cool instrument, how does your instrument matter? How can it work? How can it ensure that a scientist back home gets the information that the instrument collected? And closer to this community, a new life support system. How would that life support system be integrated into a habitat or a crew vehicle? What's the equivalent system mass of your idea? If you're a hardcore life science person, you understand the term equivalent system mass. If you're not familiar with NASA and aerospace, equivalent system mass means something like if you are requiring more power to operate your system, okay, than the existing concept, what's the penalty, the mass penalty on the mission to provide that additional power in addition to the mass and power of your system itself? All those things are things that we can discuss ahead of time if you have an idea. Now I'm going to give one sort of one sort of example that I think helps drive home the idea of what we mean by a mission concept. We have funded Len Rothschild at NASA Ames, both we funded Len in NASA Ames to look at a flexible, personalized, on-demand astropharmacy. What does that mean? It means that there's a recognized problem that pharmaceuticals have a short half-life. And you can't really expect on a mission to stock a room with all the medicines that one might anticipate needing on a mission to Mars. Even if you could, some of those pharmaceuticals won't have the shelf life adequate to make it all the way to Mars and still be useful when needed. So her solution was a production on demand concept. It is a way to synthesize the drugs using a biopharmacy, okay, this spore-forming bacterium that is coupled with a purification system that when the medicine is formed, that it can be purified sufficiently to be used by the astronauts. Her phase 1 and phase 2 lab work is investigating the engineering parts that makes this work, but she's also making sure that the concept works within a mission profile. Okay, so how much space inside the spacecraft is this astropharmacy going to take? Are the components required for this something that you could expect to include in a mission? Okay, so she is looking at more than just a lab run of producing a medicine. Okay, it's more than just, can I go in the lab, tinker around, and get the medicine out? It's not only that, which she has to explore that in detail, but also how does it work as a system to be employed on a mission? I've spent 30 years in the radiation world myself, and so I understand that in the countermeasure world, it's difficult to put a countermeasure in a mission context. And exactly how you do that is probably a case-by-case kind of thing that may involve some iteration. Again, you can talk to me ahead of the bid going out. But I think that there may be a lot of ways that this community can contribute to improving the prospects for a future mission. A more classic way that NIAC funds say radiation safety would be something like an active shielding concept, big magnetic shields that deflect the particles. Well, how much mass do they take? How much energy do they take? Is this different than other active shielding methods? Are there approaches for achieving shelter that might be different than the way that we would traditionally look at producing a deployable shelter? So there's a lot of countermeasures that would be in your world, and we're interested in your creative ideas on how that might work. And we're especially interested in hearing from the people who are not your typical NASA researcher, because we think that there are people out there who may be working on a problem and not realize at first that the solution they just came up with for that problem is relevant also to NASA. So we're trying to spread the word that NIAC is an opportunity for each and every one of you. And the future really does depend on you. While we're the most open-ended and far-reaching of NASA's technology program, we're nothing without our fellows. And we're always looking to expand our fellow pool. With that, those are all of my slides, and I think we can open it up to questions.
Thank you very much, Dr. Turner, for the presentation. I have been looking forward to asking you a few questions about this program. I see one question in the Q&A that I will get to momentarily. If you have questions, please go ahead and put them in the Q&A, and we will answer them as they come up. Just kind of to start, one of the questions that I had for you was, your program seems very focused on mission readiness and enhancing the ability of NASA to pursue manned and unmanned space exploration. Radiation Research Society has membership that typically conducts research into basic radiobiology, novel radiotherapy delivery, radiation sensitizers and protectors, epidemiology related to radiation exposure. I know you're looking for outside the box ideas, but where do you see the most overlap between the skill sets of the Radiation Research Society members and what NIAC is actually looking for?
Well, that's an excellent and also a very difficult question. But the idea, I think, it is widely known that radiation is one of the biggest risks that a NASA long-term mission has to overcome. And going from, in doing deep space missions that last a year or more. And, radiation impacts astronauts either directly or indirectly a variety of ways. We are kind of stuck in the mode these days of thinking that the only way to protect the astronauts from this radiation risk is either to shorten the time that they're exposed, let's say a much faster vehicle so the transit time is much less, or by piling a lot of shielding on so that the astronauts don't get irradiated in the first place. So, you know, we kind of have two competing mindsets. If you pile on the shielding, your trip it's going to be difficult for your trip to be shorter. If you go fast, it's going to be difficult to pile on the shielding. But maybe there's an approach that's completely different than both the shielding or the completely different from either the shielding or the fast transit. And how do you get to the core of the matter of why is radiation a challenge to the astronauts? And is there a pharmacological solution to the problem? Now, we're not going to fund you to go in the lab and do a histories-based analysis of how the efficacy of this drug versus that drug. But if you have an approach that's so different than what would normally be considered, then you have the opportunity to convince us that it's worth a look at that approach. So we don't really, if NASA knew the answer to the radiation problem, given how big it was and how big it is, you know, it wouldn't still be one of the big risks that we publish. So we want to enlist your community to be thinking about, you know, how does that risk really manifest? What can we do that might mitigate that risk? Now, notice that there's also a bunch of you out there that do radiation research, but you're applying techniques to do your research that might have spin-off applications. So it's not just your research ideas that might apply to NIAC, but it's your approach to doing your research might be tweaked a little bit and apply to a completely different problem that is another problem to NASA. So we're open-ended.
Related to that, those of us who've done radiobiology research and bench research in general, I think would find it difficult to accomplish much with the amount of funding that's available in the phase 1 portion of this program. And so one of the questions I had was these submissions and concepts, how likely are they to be funded if if the goal is actually that's just a feasibility study or a study to gather expertise from other areas to determine whether or not the idea is even possible?
Could you restate that question? Let's see, I'm having trouble wrapping my head around.
For those of us who do bench research or have done bench research, a lot of these so the advanced concepts in terms of how would we actually enlist novel radioprotectants, and would it actually be possible to do things like upregulate DNA damage response without causing damage to other systems, and those sorts of things. To actually do the bench research would take more funding than what's available with the phase 1. And so if the idea is just to put together a feasibility study where you're going to enlist a panel of experts and try and figure out whether or not there's a reason to pursue this, would something like that be of interest where you're not actually doing any of the bench work?
Well, I think that's that would depend on the details. Okay, we are well aware of your fundamental concern, right? The fundamental concern is 175K over 9 months is not going to be a very big budget for addressing some fundamental problems, and in this research world, that's not a big award. Okay, first of all, we understand that. So the challenge is trying to find out what you can do in the course of that phase one that would potentially set the stage for a phase two. And that's something that you really have to iterate with me on when you talk about your idea.
Great. One of the questions from the attendees was, what impact has AI had on your submissions, and how do you actually use AI in your evaluations? Have you had a lot of submissions that involve the use of AI or concepts using AI related to NASA mission readiness?
Okay, so there's there's two threads I want to follow here. One is, do we get proposals that propose to use AI in their investigation and use that AI to sort out some potential solutions? Sometimes we do. Sometimes the proposal is posed in a way that doesn't lend itself to selection. It's more, hey, we're gonna compile a bunch of information and we're gonna ask AI, is there a solution that can come out of this? And they may propose an innovative AI algorithm, but it's basically, you know, an open-ended study. Those don't fare well in NIAC. If you have, let's say, you can pose a very specific problem where the reason that progress is not being made is because it's intractable under the current approach to address all the variables, and therefore there is an AI solution that may help clarify a path forward for a very specific problem with a very identified data set, with a very specific end result, okay, then you might have a chance applying AI. The other thread that I want to follow is, we actually got out of our 300 step A's a few that we looked at and said, I think chatbot wrote this. So we're also getting AI'd from the other end.
One question that I had looking at your elimination criteria was, could you explain a little bit more about what you mean by aerospace architecture as it relates to the elimination criteria? Because I understand conceptually what you mean by relating it to a specific mission, but what do you actually mean by aerospace architecture?
Okay, that's a good question, because it does open up one thing. Aerospace architecture is intended to be broad and is intended to be linked to the idea of a mission. Okay, the two kind of go hand in hand. One of the challenges would be if say NIH, with a much deeper pockets and much more bountiful grant processes, if that's true, I don't apply to NIH grants, but I've heard that, is a more appropriate area to do your research, and the results apply, you know, terrestrially as well as to space, then that might be judged not really an aerospace concept. Okay, it's more of a, you know, here's a terrestrial study, and we're gonna, since it protects people, astronauts are people, it'll protect astronauts. That's less of an aerospace concept. There has to be something unique about, why would NIH not fund it? And then why would NASA fund it?
Okay. And then you have said that folks can reach out to you and the program directly. I went ahead and I was looking at the website for the program, and you have all of the previous projects that have been funded listed on there. Are there other resources beyond that that our members should be aware of when they're thinking about how to design a project, what has been funded in the past, what might be funded in the future?
There's a couple of additional videos in there that you can find by going on our website, that talk about the process that we go through to select awards, and those those understandings about what makes a good NIAC study. Those would be useful in trying to glean whether your idea, fits in a NIAC scope. They're probably not going to have a lot more detail than what, I just went through in here, but they may come at it from a different direction. So there's a variety of sort of videos like that you can link to in the website. We also have links to our symposia, which are, we have a symposium every year, generally in the September timeframe. And we have links to the past symposia. And if you're not planning on submitting a bid this year, but you want to know more about NIAC, then an excellent way to understand NIAC is to attend virtually or in person one of those symposia where you get exposed to the full range of our studies and a lot of discussion that takes place. It's a 3-day symposium that goes out on live stream. So those kind of, and we have tapes of the prior ones. They're a little cumbersome to sort through just with the posted video, but sometimes it's worth the effort. When you see what the agenda is, you can generally find the specific ideas that might be relevant. So tapes of the symposium.
Yeah, that actually relates to another question that I had for you, which is looking through the previously funded projects, there don't seem to be an abundance of concepts focused on radiobiology that have been funded, but there are a lot of concepts funded that focus on propulsion, material science, habitat development, and things like that actually could potentially benefit from the expertise of people within the Radiation Research Society community. And so in terms of connecting with folks within NIAC who have funded projects that might benefit from our expertise, would the best way to access them just be through looking at projects on the website or attending these symposia? How else could we get involved?
All of the above work. We recognize the importance of this community, which is we have this thing called the NIAC External Council. And one of our members is near and dear to many of your hearts. It's Amy Cronenberg. She's well known in the radiation community. If you already know Amy, Dr. Cronenberg, you could always reach out to her with some specific questions about. I'm sure she'd appreciate that. Or you can reach out to me on how to connect. And you're exactly right that many of these concepts could benefit from your insight. Amy, Dr. Cronenberg, when she attends our symposia every year, always interacts with the fellows, interacts with them in the phase 1 orientation meeting, and is always able to point out some issues or concerns that they wouldn't have thought of because they don't come from that background. So those interactions would certainly be appreciated. We'd love to facilitate that.
Okay. And then one last question for me that is more of a curiosity than anything else is, how did you get this job?
I got very, very lucky. It's awesome. So 20 years ago, when the University Space Research Association learned that NASA was going to be looking for and looking to establish an institute to reach out to, those fringe thinkers. Okay, USRA said, we really want to bid for this because we think we're ideal. They manage things like the Lunar and Planetary Institute and other institutes. They recognized that most of their background was on the science side and was very heavily NASA oriented. And they wanted to team with an organization that might have had insights more into the operational side and even into the defense side, because the Defense Department also has a lot of innovative space concepts that are out there. Answer was reasonably well known to the aerospace community as being involved in the defense side, and USRA started looking into Answer. They discovered that I was there with not just the defense aerospace missions, but also with an interest in NASA through the radiation side. And so they approached us, and the rest, as they say, is history, because I was delighted to help them form the bid and be a part of the original team. So that was very fortuitous on my part. I really am delighted to have been associated with NIAC for all these years.
Well, with that, unless there are other questions from the attendees, I would just like to thank you very much for the presentation today. One thing that I would like to point out to the folks on the call and the folks who watch this later is that Dr. Turner approached us and seemed to be interested in getting the Radiation Research Society folks interested in this program and potentially applying for the grants associated with this program. So I think there is interest from NIAC and seeing what we can come up with if folks within the community are interested in applying for this grant mechanism. So I think I would encourage people to dig into this a little bit more. Reach out to Dr. Turner, whose contact information is on the screen, if you have questions or you're interested. And thank you again, Dr. Turner.
So if any of you are attending the Human Research Program Investigators Workshop at Galveston, Texas, in early February, I certainly plan to attend there. And if you can look me up at that point, I'd be happy to talk with you. I should be fairly easy to find at that meeting, or send me an email saying, Ron, are you here? And we can find other ways to get together. So I'll be there in person. I'll be going to astrobiology later in the year. So the whole biology community is really underrepresented in NIAC. And we really want to find ways to tap that incredible resource of creative people.
All right, and as you can see on your screen, you can contact Dr. Turner at ron.turner@nasa.gov. Again, registrants can expect to receive a recording of this presentation via email within 5 to 7 business days. And on behalf of everyone at RRS, I'd like to thank Dr. Turner and Dr. Walker for your valuable time and expertise today. And thank you all for joining us over your lunch hour. Have a wonderful day, everyone.
Thank you very much for the opportunity.